The subject of this lecture is the photoelectric effect. So the photoelectric effect is one of those experiments which could not be explained by classical physics and needed some quantum mechanical idea to explain it. So what is the effect? So the effect is, suppose we have a metal and suppose that we shine ultraviolet light on the metal. So we're shining ultraviolet light on the metal. So then it's observed that such a metal will emit electrons. And this is the photoelectric effect. Now, of course, there's nothing unusual about this effect. There's nothing unusual about the fact that when we shine ultraviolet light on a metal, that it would spew out electrons. And that's because the electrons, which are in the metal, are supposed to absorb the energy from the ultraviolet light, and they'll be able to escape the metal. However, there were several puzzles that could not be explained. One of them was that the maximum kinetic energy of the electrons that were escaping were independent of the intensity of the ultraviolet radiation. Now this is puzzling because suppose that we have some electromagnetic wave and its electric field is given by something like, let's for the sake of argument take the electromagnetic wave to be a plane wave. And this is the amplitude. So the intensity of this wave is supposed to be proportional to the modulus squared of the amplitude. So we expect the energy imparted to the electrons to increase as we increase the intensity. But that is not what is observed. Instead, what is observed is that the intensity, as the intensity is increased, we get more and more electrons emitted. And lastly, but also very importantly, the maximum kinetic energy of the emitted electrons depend on the frequency of light. The frequency of the ultraviolet light. And if you increase the frequency of the ultraviolet radiation, the maximum energy increases linearly. And the maximum energy is given by a formula where Emax is given by h nu minus W, where h is Planck's constant and nu is the frequency of the ultraviolet radiation, and W is called a work function, and it depends on the metal. So this is in brief, the photoelectric effect.